Yeah, so I guess I can start with what NuCypher is and what it can be used for and how it can be applied in your projects, or maybe you want to build something which benefits NuCypher itself. Um, oh, oh, someone can, Mustafa cannot hear anything. Is it? But anybody else can hear? All good? Yeah, I guess so. Anyway, so yeah, what NuCypher is, it's a decentralized network which can be used to um, cryptographically share data. So you can give permissions. Well, you can encrypt data, store it wherever you like, and that you can do without NuCypher whatsoever. But let's say you want to share this data with somebody else. Well, one obvious way would be to use public key encryption and encrypt with that person's public key. But let's say you've got another person, so you encrypt with another person's public key and so on. So this process of managing permissions in GPG style becomes really unmanageable. And that's where NuCypher helps. It allows to share data while it's encrypted for just you. So um, how it works, it's using something called proxy re-encryption. And proxy re-encryption allows to transform data which were encrypted, let's say with your key, to have that data encrypted with like the key of the person you are sharing with without decryption. Um, and that's what NuCypher network is doing. So you basically say encrypt data and tell grant. And when you grant permissions, you actually create so-called re-encryption keys which are managed by NuCypher network, and they can only be used to transform data for your recipient. You can also revoke data, so revoke access to that person who you granted access to. That's kind of in a nutshell. And obviously, you can have some data sets which you, let's say, allow to read only by only only by certain people, or maybe you allow only certain parties to analyze that data, and maybe those parties can encrypt data for like some, I don't know, some policy, or let's say folder or whatever, and then you can share that analyzed data with some parties which you decided that can access that, or maybe somebody else can. So depends on how you build your application. Um, Anyway, so our network is now running on Goerli testnet. It's a little, still sometimes a little clunky when it comes to using it, but that's kind of early days, and you already can use it. The network is written in Python, so which means that if you are building something in Python, you can natively use it pretty easily. And also you can use the CLI. So what I will show today is like where to get started, how to grant like your first permission over NuCypher network using the CLI, where to look when you want to actually build something in Python. Let's say if you want to share like, I don't know, parts of pandas data frames, right? So maybe you can build something like that using NuCypher. And at the end, I will mention one thing which is which would be like really good to build, but uh, not necessarily related to NumRI. But for like what I will be telling first is, I think it's applicable to any like any data analysis platform. So could be something you can build using, let's say, Numira and NuCypher, given the topic of this hackathon. So anyway, let me share the screen and okay, where is the share screen button? And get started with that. Okay, share. Okay. And everyone can see the screen, right?
Yeah, it looks great.
Oh, okay, cool. Just right. So our like oops, our code lives in NuCypher GitHub. So you go to github.com/NuCypher/NuCypher, and there are some fixes I needed to do for the hackathon because we were kind of constantly quickly moving and breaking master from time to time. So I've created the branch hackathon demo, and that's kind of the one you will need to be using. Ooh, that's really slow. Anyway, and I will try to to do the installation process from scratch, although I did install some dependencies, and kind of will show the demo how to get set up. Okay. So let's say we are here, and yeah, I probably don't need this too. All right. Okay. And first of all, let's say you've got some machine where you've got nothing special. First of all, you need to install. You will need to have Ethereum client, and well, if you use Debian-based distro or let's say Ubuntu, you can use PPA Ethereum. So sudo apt-add repository PPA Ethereum/Ethereum. I already did it, so that's I don't need to do it again. And then you install like do sudo apt install Ethereum, and I did it too, so we don't need to do it again. Ooh, that's doesn't look fast, but anyway. And after you installed Ethereum, you've got, let's say, Geth. And you will need to have Geth running on the background. That's kind of how currently it works, although it's possible to use in Fura and stuff like that. But we've been testing it mostly with Ethereum node running side by side for now. So let's just have the Ethereum node running, and just to show you the command for that, you can run geth -- girly, and no USB is not using hardware wallets. But if you don't have no USB, you can use hardware wallets too. Okay, so let's say you're running that. It actually was. Okay. After that, let's say in this demo, we will have basically two characters who need Ethereum addresses, Alice and Bob. And Alice shares some data with Bob. Actually, in NuCypher, we make everything having a character. So whoever grants permission is Alice. Whoever can read the data is Bob. And data is encrypted by Enrico the encryptor, how we call him. And the party which is a little bit behind the scenes here, Ursula, is someone or are someone's who re-encrypt data. Okay, And well, let's just clone the repository. I already have it, but I will do it again. Oh yeah, we also need to install Python dependencies. So um, you presumably you have Python 3 installed, but you also would need probably some compilers and stuff installed and headers. So in Ubuntu, it will come down to Python 3-dev for Python headers, Python 3-pip for pip, and build essential is for GCC and stuff like that. And I already have that too. Oh yeah, and also you would need, we use the code we have on GitHub. We use something called pipenv, so you would need to do sudo pip3 install pipenv. Yeah, looks like this. Okay, and I have that too. So after that, after you've got all the dependencies installed, or well, all the global dependencies, you clone the repository, which is, so you do this. So just copy the link and do git clone. Yeah. And after that, you want to switch to, well, you go to NuCypher, obviously. And do git checkout hackathon demo, which has some kind of something to actually run the demo, some of the commands you do. I've recorded them here, as well as some bug fixes for the stuff we broke on master. So anyway, we're in this branch, and to install, to create a virtual environment in which you install NuCypher, that's how we usually do it. You run pipenv install and let's say --dev. So we'll do that. And it will install all the dependencies, all 138 of them, of NuCypher, which is like interaction with Ethereum and like all the cryptographic tools and everything. And hopefully it will be fast. And yeah, in the meantime, while it installs, I can show you like that in examples. I've got the list of commands, you can use to replicate this demo. Okay, does it work? All right, yeah, so it's a CoinList demo file. Anyway, let's see if it got installed in the meantime. Oops. Okay. See if it got installed in the meantime. Okay, we've got some failed dependencies, so it will try to install those, and it will be fast, I hope. Yeah, while it does that, I can probably also show some different resources. NuCypher read the docs page. That's the source of NuCypher documentation. So NuCypher.readthedocs.io. Okay, it's loading. Yeah, so if you go to NuCypher.readthedocs.io, you will have documentation for like different aspects of NuCypher, including the characters, classes for them, and so on. So, and yeah, and we've got all the dependencies and NuCypher installed. Well, all the dependencies, I guess, just. So you also need to do pip-env shell to jump into virtual environment. And pip install -e dot. It installs the actual NuCypher, which pip-env actually didn't install. So let's see. Okay. All right, so we've got a NuCypher installed, and I guess it's time to start doing something. So we've got this demo code. I've actually got all the character configs removed. Well, one thing which you will not have, which you will need to do, is to create a couple of Ethereum accounts. So to do it with Geth, you need to connect to your local Geth node, which is Geth attach /dot Ethereum / girly, which is the name of the Ethereum testnet /geth.itc. And once you do that, you can see the current list of accounts by typing eth.accounts. And I already have accounts for both Alice and Bob. Right? And also you can create a new account, which you will probably likely need to do by typing personal dot new account. But I don't need to do that because I already have to. Okay. And let's say, so first of all, we create configs for Alice and Bob, and have a command for that. So it's here. Oops, I think I've kind of messed up this page a little bit. Anyway, so I've got command for Alice.
Hey, Michael, one quick thing. Santiago in the chat mentioned that the shared screen is lagging a little bit. I think if you turn off your camera, it might make that a little bit better. I think you're muted now.
Yeah, it disconnected me and connected again, so and muted up after connection. You can see me now?
Yeah, I can see you now.
Okay, cool. Right. Okay. And I guess I need to share the screen again, right?
Yeah, and then when you do that, just turn off your video, and I think it'll make the shared screen experience a little bit better.
Oh, it doesn't turn my video. Wait, okay, how do I do that?
It's right next to the mute button. It has the camera icon on the left bottom hand side.
Okay, I can do this. So is the video shared?
Yep, we can see your screen and it's perfect now.
Perfect. Okay. Anyway, so we're creating configs for Alice and Bob. So for Alice, I'm choosing their account 0, and for Bob, I'm choosing their account 1. So we're creating for Alice, this is 0. And we need to choose the passphrase for NuCypher keyring. So NuCypher stores all the keys encrypted by this passphrase. Well, I'm choosing a very secure one, test password, and repeating that. Okay, and but I already got the keyring. Let me just try to remove all the NuCypher configs and try again, because I already have that, and I want to do it as if I didn't have anything. So let me just remove that. And all the NuCypher configs are stored in .local/share/NuCypher. I removed those, so we lost everything and can try to do it clean. So I'm initting Alice, which is the character which grants permissions and owns the data. And I'm copying password for the keyring. And again, and let's see. Okay, we've created Alice successfully. And then we very similarly, we create Bob. So, okay. And let's say, so it would be NuCypher Bob init. All right. And for Bob, I'm selecting account 1. And I will use exactly the same passphrase for Bob. All right, so we've created Bob. And just to show you where Alice and Bob live, they live in .local/share/NuCypher, although on Mac this directory is actually different. And there are files alice.json and bob.json. So just to show you what's there. I'm probably speaking faster than this thing is typing. Okay, and so Alice has checksum address. It has path to NuCypher keyring, says what the network is, which Ethereum provider to connect to, and stuff like that. All right, and we also will need Bob's public keys. So let's say to show Bob's public keys, we type NuCypher Bob public keys, and it will ask for Bob's passphrase for the keyring. So need to enter that. And after that, it will show basically 2 public keys. So there's 2 public keys. Why not 1? The thing is that like Bob can decrypt data, and also Bob can sign data. So and we actually need 2 of these keys. So we don't mix encryption and signing, just like it happens in GPG, because it's actually dangerous to do. And that's why there are 2 keys. So just to remember, although I guess it will be visible, I will save them. Okay, and after we've got the keys, let's do grant. So press command NuCypher ls grant, and you type all sorts of parameters which are needed for policy. So one unobvious is teacher URI. So teacher is the node which the character starts discovering NuCypher network from. And this is currently an IP address, although we have a URL for that, but this works actually better. Okay, and let's go to the next parameter. Bob verifying key. Okay, so this is actually one of those keys which we've just seen, and looks like it's good that I saved them. Oh no, actually we see that. So let me copy it from here. And then there is a Bob encrypting key. And I can copy it from here too. So this tells Alice that Alice will share it with Bob, and she will cryptographically generate the re-encryption key and give it to NuCypher network. Okay, label. So what is label? Which Alice also needs when creating a policy. So label is something which, let's say you have different sorts of data which Alice owns. It could be data in different directories, or it could be tags, or could be something else. But Alice can share with like granularity of labels. So, well, we've got, let's say, all right, I'm really sorry. Looks like I've got disconnected again. And I am sharing the screen again. Hopefully you didn't lose too much information. So I'm, uh, I've stopped at the label, and let's go further. Expiration time, right? So expiration time is like how long this policy will last for. And it's not only good to have some expiration time. It's not like only for safety. It's also how long the nodes agree to handle this re-encryption policy for, because nodes cannot be up forever. And this, like, if we have nodes which are up, like, let's say, commit to be up for even more than a year, but probably you will not be able to grant a policy which lasts for 10 years. So that's currently sort of limitation here. But for something up to a year or a little bit longer, that's fine. I'm granting a permission to Bob to be able to read the data until tomorrow. So, oops, no, I pressed enter. That's not too good. 1 second. Okay, let's continue. Oh yeah, also some other important parameters is something like we call M and N, right? Let's wait until they are inserted. Yeah, so we don't, there are actually two variants of proxy encryption. There is, well, there is like single proxy encryption when there is one proxy which transforms data from being encrypted for one person to being encrypted for the other person. But we actually developed something which splits this power between multiple nodes. And that's what we have parameters M and N for. And let me just check what happens with this terminal. I think it doesn't work for me. Yeah, sorry, I need to reconnect to Amazon because it lost my connection. So I will continue from the place where I stopped. Here we go. Okay, here we go. So I can set parameters m and n. So I'm setting m equals 1, n equals 1, which means that I'm actually choosing one node to handle my re-encryption policy instead of many. But usually it's safe, safe to do to choose, let's say, 3 or 5, or I don't know, 4 or 7 or something like that. I'm also saying how much I will pay for this policy, dash value. And for this one, it will be actually just, one way for simplicity. And I'm adding debug flag just to see what's going on if something doesn't work. Okay. Oops. It doesn't want m. That's strange. Oh, dash m. Sorry. So let's do dash m and dash n. Sorry, got disconnected again, and I'm back. And yeah, so this is how the command for granting looks like. Yeah, I will need to unlock my Ethereum account. For that, I've got just test password, and I need the NuCypher key ring, which is a little longer. Okay. And okay, so what happens now? Actually, the node first learns about NuCypher network, and debug flag just makes me having all the messages about all the nodes I learned from on my terminal, but actually without debug flag you will not see it. And it's a little slow right now. It will be faster in the new release, which is brewing. But yeah. So here a NuCypher node learns about network, and after it does that, it actually will grant permission. So what will happen, it Alice calculates the re-encryption key, gives it to Ursula node, and also creates on-chain transaction, which records that, like, which Ursulas actually share your policy, pays for that policy, and so on. So right now that transaction has broadcasted, and we are waiting for Ethereum network to confirm it. Okay, so it's almost there. Here we go. And this is some information which we will probably need. So which is treasure map, policy encrypting key, and Alice verifying key. So treasure map is something which allows you to find the node or multiple nodes who handle this policy. So it's basically a bunch of like encrypted node identifiers. Policy encrypting key is the key for which you for which the data should be encrypted when you have this tag. And Alice verifying key is basically Alice's signing public key. Okay, let's save it here, just in case we need it. And let's move on. So Alice granted permission, but granted permission for what? We didn't encrypt any data yet. And that's actually the thing. You can grant permission before any data is even created. So, and you can even remove Alice up to this point. But anyway, we probably will not remove Alice, but we need to create some data. And data is created by someone we call Enrico. And we're doing that by the command NuCypher Enrico encrypt. And what are the options? So we need to specify policy encrypting key, which we just got when we granted permission, although it can be calculated even without granting permission. Okay. The next one we need is basically a message which we are going to encrypt. So, and here is the message. And I think we don't need anything for Enrico. Enrico doesn't touch the blockchain, by the way. So it can go, after this, it can go to some storage, IPFS, and okay, and I've got disconnected again, but in the meantime, I've got Enrico encrypting the message. So we've got message kit, which is basically the ciphertext encoded as base 64, and signature, which is basically Enrico's signature, which allows us to identify that it was Enrico, not somebody else. Anyway, so we've got the text encrypted. This is this one. And let's now, and this text is actually encrypted for Alice. So let's now see if Bob can retrieve it after Alice granted Bob permissions. Bob actually can. So you run NuCypher Bob retrieve. And let's see, what parameters do you need? You need label, obviously, which is sort of like folder for us, or name of the policy, or whatever. It depends on your application. We have this again. So we've got a message kit, which is the actual ciphertext. And what else do we get? Policy encrypting key, which is, we actually saved it. Policy encrypting key, this one. Okay, what else do we need? Alice verifying key. So we, yeah, that we need that to check that it was Alice who, I guess, shared policy with us. So let's put it here. And what else do we need? Oh, we need to know who to learn about the network from. And I think that's it for Bob. Bob will also need the password for keyring. There it is. And Bob will also need to learn about network, but I think we already saved a lot about that, so it probably will be a little faster. Oh yeah, I also didn't do the debug flag, so we probably will not see the progress of Bob learning about the network, but then he will actually retrieve and print the decrypted ciphertext. And yeah, while Bob is doing that, I probably can show again where to look at. So we've got NuCypher examples, CoinList demo in Hackathon demo branch, where you can see all of this stuff. Also, you can go to NuCypher.docs.io to see the documentation and including documentation about characters or documentation about how to write demos how to write demos in Python and how to use that in your Python projects if you use Python. So there are like Finnegan's Wake demo and Heartbeat demo are kind of some of those demos. Anyway, let's see if, oh, Bob already decrypted. That's great. And so we can, this is the decrypted text. Well, it's not very human readable, of course. So to make it, it's actually base 64 encoded because it could be binary. And to see what's there, let's let's decode it in Python terminal. E64 decode. And this is the plain text. Yeah, so you can see Bob successfully managed to decrypt, and it could be like any data, not just text. Anyway, so this is like how you set up the environment and do kind of the first steps. Then you can go to explore Python characters, go to the demos on read the docs, and yeah, well, actually, actually the demos are also on GitHub in examples. They are made by like non-blockchain versions, so you probably need to tweak those. But yeah, have Finnegan's Wake demo, Heartbeat demo, and Postpone, so 3 demos. Yeah, that's one thing about using a NuCypher in your project to basically grant permissions. One other thing, NuCypher is actually a proof of stake, and it would actually be pretty good to have some good staking interface. Right now we have CLI interface, but if somebody is good at Web3 and like building browser interfaces, you can build interface for staking too. So, and there are actually some commands to like CLI commands to do staking, and these are in our NuCypher staking guide. So you basically those commands just call a Web3 provider to do staking and to like, let's say, lock coins and manage the rewards and so on. And if you feel that's that interesting, you can build a web UI for that as well. Anyway, I guess that's probably that's probably it. And please feel free to ask any questions if you didn't hear anything because of this disconnections and so on.
Does anyone have any questions for Michael? Michael, I guess one question on my end would be, can you just talk a little bit more about how the staking process works on NuCypher and how that's meant to keep participants honest?
Right. Yeah, I can say that. So basically, I probably should start like, why do we need staking for? And like in our network, you grant permissions by doing proxy re-encryption and giving re-encryption keys to nodes, to Ursulas. And you basically create, let's say, I don't know, 10 re-encryption keys and give them to Ursulas, and let's say 7 Ursulas are required to actually facilitate this permission. So imagine that we had a decentralized network like BitTorrent, where there is no coin, just everybody can run a node and serve re-encryptions. What could happen in this case? Imagine that some malicious party spinned up 1,000,000 nodes and basically flooded the network with nodes. You would have almost zero chance to give your re-encryption keys to somebody else. So you would give those just to that party who spinned up a bunch of nodes. And then imagine that this party worked for a while and then shut down those nodes, let's say maliciously, to just make the network not operating. Or maybe started censoring some particular guy that party doesn't like. So that's Sybil attack, and we would not want that to happen. And to prevent basically the Sybil attack from happening, we distribute trust in our network proportionally to how many tokens every node holds. And now with like holding or like staking those tokens, the nodes actually have they cannot really obtain too many tokens. Like they couldn't flood the network too easily because they would need to purchase those tokens first in this case. And yeah, so that's kind of the main purpose. Another purpose is if the node misbehaves and it's publicly visible, let's say if node re-encrypts incorrectly or just returns garbage, pretending that it's re-encrypted, we have a definite proof that node cheated. And if that happens, then the node's deposit gets slashed. So that's what the staking is needed for, how it keeps nodes honest. So nodes are, you distribute trust proportionally to the amount of stake, and the stake can be slashed if node misbehaves. On the other hand, by working honestly, node earns fees and also rewards from inflation in NuCypher coins.
Got it. And then another question I had was, how can the result of re-encryption be transmitted to Erasure smart contracts? And can re-encryption be triggered by an Ethereum event?
Well, re-encryption is, sorry, what was the first question?
The first question was, how can the result of re-encryption be transmitted to Erasure smart contracts?
Well, you wouldn't be able to read plain text of re-encryption securely in a smart contract, because what smart contract sees, actually every Ethereum node sees, and really everyone in the world can see, because the nature of Ethereum contracts, or maybe any smart contracts currently, is such that they are not private. It's actually very hard to make them private, and we're thinking about that, but that's a really complex problem. So smart contracts wouldn't be able to access the data securely. Because once they do, they see the plain text. It's more that you share the data offline, and you have offline, well, off-chain, I would say, Alice and Bob's reading the data. And the second question was,
it was, can re-encryption be triggered by an Ethereum event?
right. So now, not something we implemented currently, but it will be up on the network pretty soon. Not triggered by Ethereum event. It can be, I guess, filtered by Ethereum event. So imagine that Bob, like when Bob requests re-encryption, Bob can request at any time. It could be that Ursulas are able to re-encrypt or not able. So Ursulas can actually look at Ethereum blockchain, and let's say if the policy is there, and also it includes some condition from Ethereum blockchain or maybe some other blockchain, Ursulas can say, oh, actually, I can re-encrypt now, like right now, or I cannot re-encrypt now. So that's kind of an extra condition which we could get from on-chain, and that's what we will implement pretty soon.
Got it. And just kind of going back to the idea of the result of re-encryption being transmitted to, Erasure smart contracts or other smart contracts. What about proof of successful re-encryption?
Right. So actually, the proof of successful re-encryption is provided with every re-encryption automatically. And if Bob gets it, he can prove that yes, he got this re-encrypted by Ursula. We use that to prove if Ursula does not correctly re-encrypt, then Bob can produce a proof for that too. But if for your project you for some reason need a proof for correct re-encryption, it's already there. You just need to kind of look a little bit in the low level and basically use this proof for something you are building.
Got it.
And it's using some sort of zero knowledge proof, not ZK snark, something way simpler. But yeah. Oh yeah. Also, this re-encryption correctness, we actually can verify the validity of this proof, or verify validity of proof of incorrect re-encryption on chain. So it works even on Ethereum blockchain.
Got it. Awesome. I think that we have time for one more question if anyone has one. Otherwise, Michael, thank you so much for taking the time out to run through this presentation.
All right.
Doesn't look like there's anyone else with a question. Speak now, forever hold your peace. Otherwise, Michael, where can everyone find out more about NuCypher and get involved if they want to?
Right. So I guess the best way is, well, first you can go to our Discord, and you go to NuCypher.com, and there is a kind of icon link to Discord. So if you go to NuCypher.com, yeah, somehow my internet is not working well when I'm speaking. Too much multitask. Oh, sorry, I mistyped it really. Okay, so you go to NuCypher.com, and oops, okay. And let's see. Where do those links go to? Okay, so you just scroll down, click to chat, and this is our Discord actually. So I guess I can just put this link into chat really. It's a good idea. And well, of course, the NuCypher.com itself. And you can go to our GitHub. This is the branch which you use for the hackathon. And you obviously can go to their documentation and read the docs. And I guess those are the main links you need.
Fantastic. For anyone that is interested in participating in the Erasure Hackathon, that is still going on. It ends on December 17th. I will be following up to everyone on the chat with more information about that. But Michael, thank you so much for taking the time out today. And I'll let you know once the recording is up.
All right, thank you.
Have a good one.